This is Algebra 1 Credit Recovery, Unit 4 Practice. Number 1 says, if f of x is equal to negative 3x squared plus 4, find the range for the domain d is equal to 1, negative 2, negative 3. Remember that range are your y values and domain are your x values. So here we could make a table, x and y. For x, I have 1, negative 2, and negative 3. So to find the range, all I'm going to do is plug those values in from x into my function every time I see x, and that'll give me the range, or my y value. So on this very first one here, I'm going to have negative 3, 1 squared, plus 4. Okay, negative 3 times 1 squared plus 4 will give me 1. On our second one, negative 3 times negative 2 squared plus 4, make sure you keep that negative in the parentheses. Okay? That ends up giving you negative 8. And for negative 3, again, you're plugging it in. Negative 3 times negative 3 squared plus 4 is equal to negative 23. So from there, your range, you're going to use your curly braces. What you got for your range or y values are 1, negative 8, negative 23. Number 2, here we're going to identify the domain and range of each graph and classify it as discrete or continuous. Remember, for discrete functions, they're going to look like dots, and for continuous functions, everything is going to be connected. Okay, so on number 2, do I see just dots? Or is everything connected here? This one would be connected, so it's continuous. To find the domain and range, all I'm going to do is box my graph. And now from here, I'm going to go from wall to wall, seeing how far to the left and to the right it goes. And then I'm going to see from floor to ceiling how far on my y-axis it went down and how far up it went. So from here, going from wall to wall, I went from the origin. I can count that I went back 1, 2, 3, 4. So that ends up being at negative 4. Okay, what's my right wall? How far to the right did I go? From the origin, I can count, and I went right 2 times. So I go from negative 4 to 2. Remember, your domain are your x values. Okay, so for these, you're going to have your x values. Where are your x's in between? Negative 4 and 2. You're going to write your smaller number first. So negative 4 goes on the left, 2 goes on the right. From here, you're going to see that negative 4 is less than x and less than 2. Your arrows will be pointing to the left in this case. And from here, because your x is in between negative 4 and 2, let's take a look and see, do I have open or closed circles at negative 4 and 2? Here at negative 4, I can see that I have a closed circle at negative 4, so that means I'm going to have less than or equal to. At positive 2, I see I again have a closed circle, so this will also be less than or equal to. That's your domain. Let's look at your range. Same thing for your range. You want to find your floor and your ceiling, how far down from the origin you went and how far up you went on your function. So here on my origin, I count down 1, 2, 3, 4, 5, 6, 7. Okay, my graph went down 7, so I know I'm going to have my graph at negative 7. Okay, and up top from the origin, I'm going to count up 1, 2, 3, 4, 5, and it went up 5. So again, range, those are your y values, and your y's go between negative 7 and 5. Which number was smaller? Negative 7. So negative 7 goes first, 5 goes on the end. Which way will your arrows point? To the left, because you're going to have negative 7 is less than y is less than 5. Okay, because y goes in between negative 7 and 5. And from here at negative 7, you have a closed circle, so it's less than or equal to. And at 5, you have a closed circle, so it's less than or equal to. And that's how you do number 2. Let's take a look at problem number 3. This one is different because can I draw a box around all of this, or does my graph keep continuing? Here we can take a look and see that because I have an endpoint and an arrow, my graph will keep continuing in this direction. I can't draw a box around that whole thing. But let's take a look first. Is this graph discrete or continuous? This graph would be continuous because I don't have dots. It's all connected. Now let's look at domain and range. From here, let's see how far to the left or to the right did I go. My graph keeps continuing the farther I go to the left, but on the right, I hit a wall. So I'm going to draw a line, a straight line, from my endpoint up and see how far to the right or on my positive x's did I go. I went from the origin, I can count all the way over, and I end up at where x is equal to 9. Okay, so I went all the way to 9. So domain, those are my x values. I'm looking at where x is equal to 9 and seeing, is my graph to the left or to the right of 9? Is my graph, are my x values getting bigger or smaller than 9? Here we see that the graph is going to the left. Okay, so that means that my x values are getting smaller. So x is going to be less than 9. And since I have an open circle, it's not going to be equal to, and that's just how you write it. Now for my range, I'm looking at the y values. I start at my endpoint, and I can draw a line and see how far down did I go on this graph. Where is my floor? So here I can count from the origin and go down, and I see that my graph starts at y is -4. So range is my y, I'm starting at -4, and from here is my graph above or below that line. It is above, so is my graph getting bigger or smaller? In the y direction, it's getting bigger, so y is greater than -4, and it's not equal to because I have an open circle. Let's look at 4. Again, here I have 2 endpoints, so I can box my graph and see how far to the left or right did I go, how far up or down. So let's go from wall to wall. I see that I go to where x starts at -2 and it goes all the way to +4. So for my domain, I know they're my x values. Which number is smaller? -2, so that goes first. Which number is greater? 4, that goes at the end. My arrows are going to point to the left. My inequalities are going to say less than. And from here at -2, do I have an open or closed circle? It's open, so it just stays as less than. At 4, do I have an open or closed circle? It's closed, so it becomes less than or equal to. For range, I see that my graph starts at where y is 3, and it goes up to where y is +7. So from here, range is my y values. What number is smaller? 3, that goes first. What number is greater? 7, that goes at the end. Here, 3 is less than y, which is less than 7. Again, my arrows will point to the left. And at 3, is my circle open or closed? It's open, it just stays at less than. At 7, it's closed, it becomes less than or equal to. And we could have done this first, but is this graph discrete? Do I see dots? Or is it all connected? Is it continuous? This graph is continuous. Number 5, do I have 2 endpoints or do I have an endpoint and an arrow? I have an arrowhead here, so I know that this graph would keep continuing and it won't ever stop, so I can't close that into a box. Okay, but I can see how far to the left or right it went. So here, let's start at our endpoint and draw down and see how far to the left did it go on my x-axis. Here I see that it started at -3. So my domain, those are my x values, it started at -3. Is my graph going to the left or to the right of -3? It's going to the right, which means that my x values are going to increase. And since my circle is closed, it's going to be it's going to be greater than or equal to -3. Let's look at the range. Again, start at the endpoint and draw a line all the way across to see where it crosses the y-axis. Here we can see it crosses where y is at +5. So my range, those are the y values. I'm starting at 5, and is my graph above or below the line at 5? It is below, so y is going to be less than 5, And since it's a closed circle, it's going to be less than or equal to 5. Here, discrete or continuous. Do I see dots or is it connected? This graph is connected, so it is considered continuous. Number 6. Is this graph discrete or continuous? Do I see dots or is it connected? I just see dots, so it's discrete. Number 7. Do I just see dots or is it connected? Again, I just see dots. Dots means that it's a discrete graph. Number 7. Which of the following relations is not a function? In order for it to be a function, your x's can't repeat. So if it's not a function, that means that your x's repeat. Let's look at the x values of each of these. On A, do any of my x values repeat? I have a 3 and a 3. Yes, they do, so that means that this one is not a function. Let's check the rest of them. B, I have 4, 6, and 5. Those are all different. C, I have 3, 5, and 9. Those are all different. And D, I have 7, 8, and 6. Those are also all different. So 7 is A. Number 8. Which of the following represents y as a function of x? All that is saying is which one of these is a function. In order for a graph to be a function, it needs to pass the vertical line test. Meaning, if I draw a vertical line at any point in the graph, it should only touch my graph once. On A, I can see here that my line actually touches my graph twice. So this one is not a function. On B, again, my line touches twice. That is not a function. C, this vertical line only touches once. In D, I can draw a line directly over that vertical line. So there are multiple points, infinitely many points, that my graph will cross that vertical line. So which one of these is a function? C, because C passes the vertical line test. Number 9. Which of the following relations is a function? Again, for it to be a function, your x's can't repeat. So let's look at this. On 1, I have 3, 4, 3. So 3 and 3 repeat, so that is not a function. On 2, I have 3, 4, 5. Each of those x values are different, so it is a function. On 3, I have 3, 3, 3. My x is repeated there, so that means this is not a function. And on 4, I have 3, 4, 5. Those don't repeat, so it is a function. So the answer here would be graph or function 2 and 4, which gives me B. 10. Which of the following graphs does not represent a function, y as a function of x? So that means which one of these does not pass the vertical line test? Let's see. On A, if I draw a vertical line, did that pass my graph more than once? Nope. What about B? Did it intersect more than once? Nope. C? Yes, it did. I can see that my vertical line intersected my graph here and here. That was more than once, so that would not be a function. And D, it only crossed once. So here, which one is not a function? That would have been C. Let's look at 11. On this one, it gives me f of x is equal to x squared minus 5, and g of x is equal to negative 4x plus 2. We need to find each of the following. So here it says f of negative 3. This means I'm looking at the function f of x, where x is equal to negative 3. Notice this negative 3 is in the parentheses, and that replaces what was in my parentheses up there, which is x. So all I'm going to do with that negative 3 is plug it back into my function every time I see x. So here I'm going to put negative 3 squared minus 5. I can plug that all into my calculator. Negative 3 squared minus 5 just gives me 4. Let's look at problem 12. This one's talking about the function g of negative 2. Again, negative 2 is x, but now I'm looking at my g of x function. So I have negative 4 times negative 2 in parentheses plus 2. Plug that into your calculator. What should you get? It should be 10. Let's look at 13. Here now I have g of negative 1 minus f of 2. Let's solve for each of these separately. So g of negative 1, we're going to plug negative 1 into the function for g. So I'm going to have negative 4 times negative 1 plus 2. Negative 4 times negative 1 plus 2 should give me 6. Let's find f of 2. Okay, plug in 2 for x in my function f of x. So I'm going to do 2 squared minus 5. 4 minus 5 gives me negative 1. So from here, g of negative 1, I got 6. I'm going to subtract what I got for f of 2, which is negative 1. 6 minus a negative 1 gives me 7. And I'm going to go ahead and box each of these answers so that we can see it clearly here. 6 more problems here. On this one, I have if f of x is equal to each of those points, find each of the following. So for these, again, this is function notation. It's asking me what is y when x is negative 1. So here I'm going to find the point that has x for negative 1. I see that up here. When x is negative 1, what is y? It is just 5. Let's take a look at the next one here. F of negative 2. When x is negative 2, what is y? I see that right here. When x is negative 2, y was equal to 7. Number 16. Now I have to find each of these first. When x is negative 1, what was y? Y was 5. Minus, when x was 2, what was y? It was negative 1. So 5 minus a negative 1 leaves me with positive 6. 17 is a little bit different. F of x, that's actually just a fancy way of saying y. So this is asking when y is equal to 5, what is x equal to? So take a look here. I see y is equal to 5, so x was actually equal to negative 1. 18. If x is equal to 2, find f of negative 2 plus x. So they told me what x is equal to here, and I need to plug it in to my parentheses. So I'm going to have f of negative 2 plus 2, which is the same thing as f of 0. So again, this is saying what is y when x is 0. So I see that x is equal to 0 here, which means that y was equal to 3. And on my last one, 3 times f of 5. So first let's find f of 5. What is y when x is equal to 5? Okay, let's take a look. I see that right here. When x is equal to 5, what was y? Negative 7. But I need to multiply negative 7 by 3. 3 times negative 7 gives me negative 21. And that's your final answer. And this is the end of this video.